I want to talk a little bit about p-series, and I hate doing this kind of thing, but I'm going to have to be upfront with you on this particular case. I actually have a p-series video. It's a great p-series video. There's one problem. The p-series concept is proved using calculus, and obviously in a pre-cal class we don't have the background to be able to prove what I'm getting ready to show you. So you're just going to have to kind of take this for what it is at the moment and go from there. So p-series are a very, very recognizable type of series, and it's very easy to tell if a series converges if you can identify that it's a p-series, okay? So here's the deal. P-series are always going to be of the form 1 over n to the p power. Okay, so that might be 1 over n squared, 1 over n cubed, technically 1 over n is an example of a p-series. And it's very easy to tell if the p-series is convergent or divergent. If p is greater than or equal to 1, the series is going to converge. Very easy to prove with calculus, not so easy to prove with pre-cal. If p is 1 or less, the series is going to be divergent, okay? So I want to look at just a couple of examples of things that you might see here with p-series. Number one, the p-series with n equals 1 is the harmonic series, okay? It's just 1 over n, right? The p-value there would be equal to 1 in this particular case. And this would just be the series 1 over 1 plus 1 over 2 plus 1 over 3 plus 1 over 4, and so on. If you remember, the harmonic series is divergent, okay? So that's not really a proof, but I have a proof of the harmonic in a different video. Any multiple of the harmonic is also going to be divergent. So for example, if I had something like 5 over n, you can always factor a constant out. So 5 over n would be 5 over 1 plus 5 over 2 plus 5 over 3, and so on. Notice that's exactly the same thing as if I just factor out all the 5s and just multiply each of the terms by 5. So you can always factor out a constant. The sum from 1 to infinity of 5 over n is the same as 5 times the sum of 1 over n, okay? Same thing. So any multiple of that p-series with an n value, with a p-value of 1 would be a divergent series, okay? If 1 over n is divergent, 5 times 1 over n would also be divergent, okay? So other things you might see a series like 3 over radical n, something like that. And again, you can factor a constant out, totally okay. The square root of n is the same thing as n to the 1/2 power, okay? And that's a p-value that's less than or equal to 1. So as a result, that is going to be a divergent series, okay? If you have something greater than 1, then it's going to be convergent. So for example, if I have 1 over n squared, this will be a convergent series. And again, that would be 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared plus 1 over 4 squared. You can see these individual terms are dropping very quickly to 0. And interestingly, they're dropping a little bit faster than the regular harmonic. And so this will actually approach a sum, okay? We aren't going to be able to figure out what that sum is, okay? We're just going to be able to tell that the series does converge because the p-value is 2. And since 2 is greater than 1, that's a convergent series, okay? Let's see, other things you might see. You might see something like this series, you might have something like n squared times radical n. Of course, that's n to the 1/2 power. That would be the same thing as 1 over, well, that's 2.5 if you add those. That would be the same thing as 1 over n to the 5 halves, okay, that's a p-value greater than 1, so once again, that would be a convergent series, okay? It's also possible that you won't be given the series, that you won't be given, like, the general formula for the series. So maybe you'll just be given a series like 1 plus an 8th plus a 27 plus a 64th. Maybe you'll have something like that, and you'll notice, oh, 1 cubed is 1, 2 cubed is 3, 3 cubed is 27, 4 cubed is 64. We can say that the general term is 1 over n to the 4th, and we're starting out at 1 and we're going to infinity. And again, you can start at 0 and go to infinity, you can start at 7 and go to infinity. But the point is, because our p-value is 4 here, and our p-value is greater than 1, this is going to be a convergent series. So sorry I can't really explain why the harmonic doesn't converge, and a lot of these other ones will converge. But the p-series test is relatively easy to use, and it's going to work very closely with a lot of the comparison test problems that we do, and that'll come up in a different video.